Hello everyone, welcome back to my channel. My name is Navneet Kumar and I'm a student of Sri Venkateshwara College of Engineering. Today we'll learn about functions in discrete mathematics. So let's dive into our video. Right. So first of all, we'll go with an overview of what we're going to learn today. We'll go with introduction, domain, range and codomain, what it does, types of functions, composition of functions, inverse function, identity function, polynomial, exponential and logarithmic function, monotonicity and periodicity, and applications and conclusion. Right. So let's see one by one. So first of all, what is a function? So a function assigns exactly one element of a set to each element of that other set. So functions are the rules that assign one input to one output. Okay, so the function can be represented as f of a to b, where a is called the domain of a function and b is called the codomain of the function. Basically the b is derived from a. Okay, so examples are linear function we have, which goes in a linear structured, quadratic we have, then we have exponential. So an important thing is functions are fundamental in various area of mathematics, right? Whether it is computer science, medical, engineering, anything it is. So it basically describes a way of relationship between sets of values or data, whatever you say, right? So when we go with the three topics, which are domain, range and codomain, we see that the domain of a function is set of all possible input values, usually in the form of x, that the function can accept without causing any issue such as division by 0 or taking the square root of a negative number. Okay, now not only that, but the range of a function is the set of all possible output values, which are usually denoted by y, that the function can produce when you plug in the values from the domain. Okay, and last but not the least, the codomain is the set of all possible outcomes of a given relation of a function. Sometimes the codomain is equal to the range of the function, however the range is a subset of the codomain. Okay, so it's basically domain has most of the input values, the range is or whatever the possible values of the output values, and the codomain is all the possible outcomes given by the relation. That's it if we go with the basic explanation, right? So we have three types of different function, which is injective, surjective and bijective. Okay, so what is injective? Injective is one to one function. Here what it does is that it defines that each element of one set, say set A, is mapped with a unique element of another, say let's say set B. Okay, so a function g is one to one in every element of the range of g corresponds to the exactly one element of the domain of the g. Okay, you can see here how it is mapped, right? 0 to 0 0 0, like it's like the part, it's the value. Okay, so if f of x of 2x is there, so like if the value of x is there, the f of n x will be 2. If it is 2, it will be 4. So you can see each value is assigned to a different value. Similarly, f of x is x plus 3. We see for 1 it is 4, for 2 it is 5. So that is how it works. So injective is one to one function. When we go surjective, it is on to function. If we say it in a normal way, it will be like for every element of B, there is should be at least one or more than one element matching with A, right? So then the function is said to be onto function or surjective function. So if a function f is surjective if every y in the codomain is mapped by at least one x of the domain, right? So for example, if we say that the output value of b should is 1, then for that we should have two different inputs like x and y in the surjection, right, the left side. But whereas in here we don't have it because one value, which is 4, is left out, right? So we have this, for this we have examples as f of x is equal to x cube, right? So we have that. Now bijective function, if we say one to one correspondence, like a function is said to be bijective or bijection if a function f of a to b satisfies both injective and surjective. Okay, it means that every element in B in the codomain, there is exactly element A in the codomain, such that f of A is equal to B, right? For like example, we have here f of x is equal to x, or f of x is equal to 2x plus 1, right? So if here we give 1 here, it should be 3, or 1 is equal to 1. Like for each element, there should be another element, and they should be interrelated, right? So if we see little bit of more variations, right, like the difference between each, so we can say injective, which always maps distinct element of its domain to the distinct element of its codomain. Okay, it is also known as one-to-one function. Surjective is which maps more than one more element of A to the same element of B, and it is also known as onto function. And bijective is which is both injective and surjective, which is known as one-to-one correspondence. Okay, so now what we see is composition of functions. Composition of functions is the building of complex function using the simple function. It is the process of combining two or more functions into a single function, right? So basically we have a, let's say, a function f and a function g, which goes from a to b and b to c, two functions, right? Then the composition of f of g is denoted by g on f, is defined as function g on f, which is given a to c, right? So this is one example, right? Here it is written as g on f, which gives g on f like this, with for all x belonging to a. So we can see now inverse function. Okay, how this inverse function works. Okay, so here an inverse function, or we can also call it as anti-function, is defined as a function which can reverse into another function. In simple terms, if any function f takes x to y, then inverse of f will take y to x, a reverse thing basically, just that the name says. So if the function is denoted by f or f, then the inverse is denoted by f of minus 1 or capital of minus 1, right? You can see here, if we go 1 to a, f of inverse will go from a to 1, 2 to b, b to 1, 3 to c, c to 3, 4 to d, d to 4. This is how it works. So if we go for a function with, let's say it's x plus 2, then the inverse will be x minus 2. If it is 2x, it will be x by 2, right? So now we go with what is identity function. The identity function is a function which returns the same value which was used as its argument. So let's say if f is a function, then identity relation for argument x is represented as f of x is equal to x for all values of x. So in terms of relation and function, this function f of p is defined by b is equal to f of for a for each a belonging to p, where p is a set of real number, right? So here x goes to the function and gives us an x value, right? Because same value is coming out. So we can see the relation between a and a is same. If one is given to the function, one is out. Yeah, the best example is f of x is equal to x. Okay, this function, identity function it is, where the input value and the output value is same after going through the function. Okay, now what is polynomial functions? Okay, so polynomial functions involve terms with variable raised to non-negative integer power combined with constant coefficients, like linear we have, which is m of mx plus c, where m and c are constants, right? We have quadratic, which is ax square plus bc plus c, where a, b, c are constants, right? Or we can go with cubic also, which is ax square, ax cube plus bx square plus cx plus d, where a, b, c, d are constants. These are some of the polynomial functions. When we go with exponential and logarithmic functions, we can see that it expresses rapid growth or rapid decay, right? While logarithmic functions provide the inverse relation measuring the power to which the base must be raised to achieve a given value. We can see in this two graph how the exponential function is going getting a rapid growth, or if from here if we see, it is going to a rapid decay. While here we are seeing how what should be the proper value to get the value which is needed to be achieved, right? So we have now coming across monotonicity, tonicity, whatever it is. So functions are known as monotonic, if they are increasing or decreasing in their entire domain, right? Like if a function in only one domain only it is increasing and decreasing, then we can say that this thing is monotonic. So monotonicity it is. So importance is we have to understand the, it helps us understanding the function trends. Now periodicity. Okay, so a periodic function is a function that repeats its value in regular intervals or periods. So it is basically, it keeps measuring at a specific period what will be the value of the graph, and it keeps repeating sometimes, right? We can see in ECG also how it works. So what are the application? It helps in signal processing and wave functions. Okay, so now if we see real world application, we can see that they are building fundamental building blocks in discrete mathematics used in various applications, from solving equation to modeling real world program or phenomena, which is graph theory, which represents an analyzing relationship between objects, computer science, which helps in developing algorithm and data structure, probability and statistics, which helps in modeling random events, analyzing data, and combinatorics, which helps in counting arrangements and combinations. So in conclusion, we can say that functions in discrete mathematics serve as fundamental tools for modeling relationship between sets, offering precise mapping that preserve unique elements and ensure structured transformation. And by exploring properties such as injective, surjectivity, and bijectivity, we not only classify functions but also harness their power to solve diverse computational and theoretical problems. Not only that, but understanding these properties not only enhance our ability to analyze discrete structure, but also lays a foundation for exploring more complex mathematical and computational frameworks. So with this, I would like to thank you guys for listening to my video. If you guys like, please drop a like. If you guys have any doubt, comment me. I'll reach you out, and subscribe to my channel and share as much as you want. Thank you.